Anthropic built the model Beacon Labs runs every single day. And yet, Anthropic cannot see one prompt that model processes. Not a patient record, not a clinical protocol, nothing. For a company bound by HIPAA, that one fact is the difference between using this service and never touching it. Stack lessons here. Let's settle this topic for good. By the end of this video, you'll know exactly what Amazon Bedrock is, why its data privacy guarantee makes it usable in regulated companies like healthcare, and the one scenario that separates Bedrock from SageMaker. This topic anchors the highest weighted domain on the Amazon Web Services Certified AI Practitioner exam. In episode 7, you learn what tokens and embeddings actually are, why foundation models get billed per million tokens, and what makes a model a foundation model. In episode 8, you learn where grounding fits in. Now we get to the service that actually delivers those foundation models to Beacon Labs. This is where the abstract ideas become a thing you can call. 4 terms will anchor everything in this episode, so let's pin them down first. Serverless means Amazon Web Services runs and scales all the infrastructure for you, no servers to provision, and on demand, no cost when you're idle. A model deployment account is an Amazon Web Services owned account, one per provider, where Bedrock runs a copied model so the original provider can't see your data. On-demand versus provisioned throughput are the 2 ways to pay per token with no commitment, or reserve guaranteed capacity for an hourly rate. And HIPAA eligible means Amazon Web Services will sign a business associate addendum for protected health information, though you still have to configure everything correctly to actually be compliant. Start with the problem. You want Claude, or Llama, or Amazon Nova powering your application. What you do not want is the fleet of GPU servers sitting behind those models. Running that infrastructure yourself means capacity planning, scaling, patching, and a separate contract with every provider. And here's the part that stops a company like Beacon Labs cold, sending a prompt full of patient data straight to an external provider's own API is a legal non-starter under HIPAA. Bedrock answers all of it with one API and one privacy guarantee. Here's how Amazon Web Services defines it in their own documentation. Bedrock is a fully managed service that provides secure, enterprise-grade access to high-performing foundation models from leading AI companies. Notice the words that are doing the work there. Fully managed, so you run no infrastructure. Secure and enterprise-grade, which we'll unpack in a moment. And foundation models, plural, from leading companies, meaning many providers behind one front door. Here's the mental model to hold on to. Using Bedrock is like plugging an appliance into a wall outlet. You don't build a power plant, you don't run the wiring, and you don't babysit a generator. You plug in, and you pay for the kilowatt hours you actually use. The power company handles everything upstream. That's exactly the relationship you have with a foundation model on Bedrock. Let's look at the shape of it. On the left, your application makes a single API call. That call goes to Amazon Bedrock in the middle. And from there, Bedrock fans out to more than 100 foundation models. Amazon's own Nova family, Anthropic's Claude, Meta's Llama, then Mistral, DeepSeek, and others. The important thing is that switching models is a change to one field in your request, not a new integration and a new vendor contract. One door, many models, and no servers of your own anywhere in that picture. Let's be precise about what serverless buys you here. There are no EC2 instances to launch, no endpoints to size, and no capacity planning to get wrong. On the on-demand model, when your app isn't calling Bedrock, you're paying nothing at all. That zero idle property is going to matter a lot when we compare Bedrock to SageMaker later, so keep it in mind. Quick checkpoint on where we are. So far, we've only built the mental model. Bedrock is serverless, managed, multi-provider foundation model access. Next comes the fact that makes it usable at a clinical company at all. After that, we'll cover pricing, the 4 building blocks, and the one comparison the exam leans on hardest. Now the fact to remember above all others. Straight from the Bedrock frequently asked questions, Amazon Web Services and the third-party model providers will not use any inputs to or outputs from Amazon Bedrock to train Amazon Nova, Amazon Titan, or any third-party models. Read that carefully. It names Amazon's own models and everyone else's. Your prompts don't train the base model, and they never reach the provider. This is the single most important Bedrock fact for the whole exam. Here's why that unlocks Beacon Labs specifically. They run clinical and regulatory data under both HIPAA and GDPR. Their prompts can contain protected health information that legally can never reach an outside party. Because a prompt on Bedrock never trains the model and never leaves the Amazon Web Services security boundary, the service fits their compliance posture instead of breaking it. This is precisely why System B, their clinical trial protocol summarizer, runs on Bedrock rather than calling a model provider's API directly. Same model, completely different data path. Picture it as a secure vault that Amazon Web Services built inside its own data center. Anthropic or Meta or Mistral delivers their model to the vault's loading dock. Amazon Web Services makes a certified copy, locks it inside, and then changes the locks. The original provider does not have a key. They can't see who opened the vault, what was brought in, or what happened inside. That's not a marketing promise. It's the actual arrangement, and next we'll see the architecture that enforces it. The model provider ships their model to Amazon Web Services, and Amazon Web Services performs a deep copy of it into what's called a model deployment account. In each region, there's one of these per provider, and Amazon Web Services owns and operates it. The provider does not. Inside that account sits the copied model, along with your prompts and completions flowing through it. Because the provider has no access to the account, they have no access to its logs, and no access to your data. That yellow box on the right captures what matters architecturally. This is a hard technical boundary enforced by account isolation, not a contractual agreement. Now, a critical distinction for any regulated workload. Bedrock is HIPAA eligible, but eligible does not mean compliant. On the left is what Amazon Web Services gives you. They'll sign a business associate addendum. The service supports use with protected health information, and the infrastructure meets the bar. On the right is your half of the deal. You configure IAM and access controls correctly, you encrypt your data, and you operate the workload according to HIPAA's rules. That split is the shared responsibility model applied to AI. Your compliance posture depends entirely on how well you hold up your side of that line. Now let's talk money, and this builds directly on the token pricing you learned in episode 7. Bedrock bills per million tokens, split into 2 buckets. Input tokens are your prompt plus any retrieved context you feed in. Output tokens are what the model generates back. Output tokens usually cost several times more than input tokens because they're produced one at a time rather than read in parallel. And here's the lever that drives everything. The model you choose can swing your costs by more than 100 times for the exact same request. Look at the spread on input pricing per million tokens. Amazon Nova Micro sits at 3.5 cents. Nova Lite at 6 cents. Nova Pro jumps to 80 cents. And current generation Claude Sonnet lands at $3. That's roughly an 85-fold difference between the cheapest and the priciest on this slide alone, and the gap gets wider once you include frontier tiers. Rates change often, so always check the official Bedrock pricing page, but the shape of this spectrum is the point. Your model choice is your biggest cost decision. Nova Micro's cost profile, 3.5 cents per million input tokens, means high volume, low complexity work becomes economically trivial at scale. Classifying content, routing requests, tagging text. At that price point, the cost of the model itself effectively vanishes. That's a genuine engineering advantage, not just a budget footnote. The exam reflects this same reality when a scenario calls for the lowest cost option on a high volume task that doesn't need frontier reasoning. Nova Micro is the right call. Save the expensive frontier tiers for the genuinely hard reasoning. There are two ways to pay, and the analogy makes it stick. On demand is like paying per gym visit. You're billed per token. There's no commitment. It scales to 0 when idle, and it's ideal for variable or low volume traffic. It's the sensible default. Provisioned throughput is like a monthly membership. You reserve model units and pay an hourly rate whether you use them or not. In return, you get guaranteed capacity and predictable latency. And 1 month or 6 month terms drop your per token cost. That's the model for high volume, predictable production. The choice between on-demand and provisioned throughput flows directly from your workload's traffic pattern, variable or bursty traffic. On-demand scales to 0 and keeps costs low. You pay only for what you use. High, steady, latency critical volume. Provisioned throughput guarantees capacity and cuts the per token rate. The traffic pattern is the decision. Everything else follows from that. We're 2/3 of the way through. You've now got serverless multi-provider access, the privacy guarantee and how it's enforced, and the pricing model. Next up are the 4 building blocks that sit on top of raw model calls. Then we'll finish with the one comparison the exam leans on hardest: Bedrock versus SageMaker. Bedrock is more than a pipe to a model. On top of raw model calls, it adds 4 managed capabilities you'd otherwise have to build yourself. The first is knowledge bases, managed retrieval augmented generation over your own documents. The second is agents, which let the model take multi-step actions rather than just answering. And rounding it out are guardrails for safety and prompt management for versioning. We'll preview each one here. Everyone gets its own deep dive episode later in the course. Building block 1 is knowledge bases, and it's Bedrock's managed take on RAG, the retrieval augmented generation you met in episode 7. Think of it as a research assistant who has memorized your entire filing cabinet. You ingest your documents, Bedrock chunks, and embeds them into a vector store. And at query time, it pulls the most relevant passages and hands them to the model. The answer gets grounded in your current proprietary data with no retraining of the base model. That's exactly Beacon Labs' protocol Q&A use case. Building block 2 is agents. This is where the model stops just talking and starts doing. An agent can plan a multi-step task and call defined actions, Lambda functions or APIs, to actually complete it. Ask it where an order is, and it can call the order system, then the shipping system, and synthesize the result on its own. It turns passive question answering into active task completion. This connects straight back to the agentic AI idea from episode 2. Building block 3 is guardrails. Think of it as a bouncer stationed at both the door and the exit. It checks incoming prompts and outgoing responses. It gives you content filters, denied topics you define in plain language, PII detection with block or mask actions, and contextual grounding checks. That last one is the same feature Beacon Labs uses to make sure its summarizer never invents a dosage. And it's model agnostic. Through the Apply Guardrail API, you can even wrap models that aren't hosted on Bedrock at all. One thing to keep straight: Guardrails is not SageMaker Clarify. We'll draw that line clearly in a moment. Building block 4 is prompt management, and it's version control for your prompts. You store, version, and share prompts with structured metadata so you can always trace which prompt version produced which result. For a company with audit trail obligations like Beacon Labs, that reproducibility isn't a nice to have. It's how you prove, months later, exactly what the system was asked and why it answered the way it did. Let's settle the mix-up before it costs you. Bedrock Guardrails, on the left, is a generative AI safety layer. It blocks harmful content, masks PII, enforces denied topics and grounding, and it lives in the Bedrock console. SageMaker Clarify, on the right, is a completely different tool. It detects bias in traditional machine learning models and gives you explainability and feature importance. It's what Beacon Labs uses to audit System A, their adverse event classifier, and it lives in the SageMaker console. The clean separator, Guardrails guards generative output, Clarify inspects traditional models for bias. Now the comparison that matters most on this exam, and Amazon Web Services draws the line for us in their own decision guide. Bedrock is serverless, meaning you don't have to manage infrastructure. SageMaker AI is primarily serverful and gives you granular control over compute resources and scaling. That word pair, serverless versus serverful, is the heart of the distinction. Let's expand it. Here's the full picture side by side. Bedrock, on the left, is for consuming pre-trained foundation models through an API. It's billed per token, and you can be running in minutes with minimal machine learning expertise. It's also serverless, so there's no infrastructure to manage. SageMaker AI, on the right, is for building, training, and hosting your own models. It's serverful, so you manage the compute and the endpoints. You're billed by instance, storage, and data transfer, and it's aimed at data scientists who need full control. One consumes, the other builds. If you want one image to remember it by, use this. Bedrock is a fully furnished apartment. You move in today, you pay monthly, and the landlord handles all the maintenance. SageMaker is a plot of land where you build a custom house, total control over the floor plan, but you need construction expertise, and you maintain the property yourself. Rent versus build. That's the whole comparison in 4 words. And notice Beacon Labs uses both, which is exactly why the distinction is worth internalizing. System B, the protocol summarizer, consumes a foundation model on Bedrock. System A, the adverse event classifier, was trained on their own labeled patient data and hosted on SageMaker, and they deliberately kept it as a supervised classifier for its determinism and auditability. The signal word decides which service you're looking at. Consuming a pre-trained foundation model points to Bedrock. Building, training, or fine-tuning your own model from scratch points to SageMaker. So here's the decision as a single question. Are you consuming a model or building one? If you're consuming, go left, Amazon Bedrock, serverless foundation model access. If you're building or training your own, go right, SageMaker AI, where you train and host it yourself. One nuance to hold on the bottom of the slide. Bedrock can also fine-tune a handful of select models on your data, and that's still fully serverless. It is not the same thing as SageMaker training a model from scratch. So fine-tuning an existing foundation model on Bedrock still lands you on the Bedrock side of this question. Let's lock it in. Bedrock is serverless, managed, multi-provider foundation model access through one API. Your prompts never train the base model and never reach the provider, enforced architecturally by model deployment accounts. Choose on demand for variable workloads and provisioned throughput for high predictable volume. The 4 building blocks are knowledge bases for RAG, agents for tool use, guardrails for safety, and prompt management for versioning. And if you remember nothing else, consume a pre-trained foundation model means Bedrock, while build, train, or host your own means SageMaker. That privacy guarantee and that consume versus build line are the 2 ideas to carry out of this episode. Now let's see how well it landed with a quick 5-question quiz. Let's test what you've learned. Question 1. A healthcare startup wants a generative AI assistant built on a pre-trained foundation model, and their legal team insists that patient data and prompts must never train the model and never reach the provider. Which service and property satisfies this? Option A, SageMaker AI, because you host the model yourself on private endpoints. Option B, Bedrock, because prompts never train the base model and providers have no access via model deployment accounts. Option C, Bedrock, because Guardrails encrypt every prompt before it reaches the provider. Or option D, Amazon Comprehend, because it processes text without any foundation model. Pause here if you want more time. The right call here is B. Bedrock's guarantee is that your inputs and outputs never train any base model, and the model deployment account architecture means the provider has no access to your prompts at all. Option C names the wrong mechanism. It's account isolation, not Guardrails encryption, that enforces this. Question 2. A team runs a customer-facing assistant with steady, high, round-the-clock traffic that needs guaranteed latency, and their on-demand token bill has ballooned. What should they switch to? Option A, provision throughput, reserving model units on a 1-month or 6-month term. Option B, a cheaper region, since on-demand rates are always lower elsewhere. Option C, serverless inference on a SageMaker endpoint to scale to 0. Or option D, stay on demand because it's always cheapest. Lock in your answer before I give it away. The right call here is A. High, steady, latency critical volume is the textbook case for provision throughput. Reserved model units give guaranteed capacity and a lower effective per token cost, and a longer commitment lowers the hourly rate further. Option D is the wrong mental model. On-demand is not always cheapest once volume is high and predictable. Question 3. A data science team needs to train a custom fraud detection model from scratch on their own labeled transaction data, with full control over training instances and the deployed endpoints. Which service fits? Option A, Bedrock, because it provides access to many foundation models. Option B, Bedrock knowledge bases, because it can ingest the transaction data. Option C, SageMaker AI, because it builds, trains, and hosts custom models on managed compute. Or option D, Bedrock agents, because they can call the training API. Run the consume versus build rule before you answer. It has to be C, and here's why. Building and training a custom model from scratch with control over the compute and the endpoints is the defining SageMaker use case. The signal words are build, train, and full control. Bedrock is for consuming pre-trained foundation models, not constructing your own from the ground up. Question 4. A generative AI application on Bedrock must block hateful content, prevent certain forbidden topics, and mask personally identifiable information in the model's responses. Which capability provides all of this? Option A, SageMaker Clarify, which detects bias and provides explainability. Option B, Bedrock Prompt Management, which versions and audits prompts. Option C, Amazon Macy, which discovers sensitive data in S3. Or option D, Bedrock Guardrails, which filters content, enforces denied topics, and masks PII. Think about which service actually sits on the model's output. This one is D. Guardrails is the generative AI safety layer applied to both prompts and responses, content filters, denied topics, and PII detection with masking, all in one place. Option A is the classic distractor here. Clarify detects bias in traditional machine learning models. It is not a content safety layer for generative output. Question 5, and this one tests a concept from an earlier episode. A team needs an assistant that answers questions from clinical trial protocol documents updated every week, and the answers must always reflect the latest documents without retraining the model. Which approach fits? Option A, fine-tune the foundation model weekly on the new documents. Option B, retrieval augmented generation, retrieving the current documents at query time. Option C, increase the context window so the model memorizes all documents. Or option D, switch to a larger frontier model with more training data. Got your pick? Let's see. If you said B, well done. Retrieval augmented generation pulls the current documents in at query time, so answers reflect the latest content with no retraining, which is exactly what weekly updates demand. On Bedrock, knowledge bases is the managed way to build this. Fine-tuning in option A bakes knowledge into the weights and can't keep up with weekly changes. That finishes Amazon Bedrock, the managed foundation model platform. Subscribing is genuinely what keeps these lessons free and in front of new students, so if you can, please do. Tell me in the comments what helped most. If there's a certification you'd love a series on, drop it below. Your requests decide what's next. And any thoughts on improving the pace or the visuals? I'm listening. Thanks for watching the Amazon Web Services AI Practitioner Prep.